From the Keith Vincent Kaola Studios in Paterson, New Jersey, Green Arrow Media proudly presents Is This Real Tonight? The JWST photos. We'll take a look. And now here's your host, JC3.
Hey there, fellow truth seekers. Are you ready to dive deep into the mysteries of the universe? Look no further than IsIsraelPC.com, your one-stop destination for all things mysterious and unexplained. From captivating podcast episodes to thought-provoking articles, our website is packed with fascinating content that will leave you questioning reality. Visit IsIsraelPC.com today and join our community of curious minds as we explore the unknown together. Don't just wonder, discover the truth today at IsIsraelPC.com. Welcome everybody to another fantastic episode of Is This Real? I'm your host, JC3, as you can see. It's very, very sad tonight. It's just the three of us in the booth. As you can see, I'm JC3, and you have Pope Tony on this side.
I'm at the Pope.
And you have Big Joe over there. So it's just me, the Pope, and Big Joe. That's the only three in the booth tonight. And as you were saying, Dad, we are talking about the JWST photos, which has been a thing over the past couple of years. Because when did the JWST start, Anthony? Because
I know
for you, Anthony, you've been on the JWST stuff for a while, and that's how our TikTok actually started blowing up because of the JWST photos.
Yeah, like the first real big one that came out was, I think it was 2 years ago when they put out the pictures of the Pillars of Creation. Mm-hmm. And I made a video about it, and it got a couple million. I think it got 1 million views on it.
Yeah,
so.
1.3, I believe. The second one. The first one only has 800,000. But yeah, so that this telescope actually has taken very high definition photos. They're compilation photos, like every telescope. It's data that comes together, and that's what we make. These are what telescopes do.
Correct. For those, let's put something out there right now. For people who think that telescopes just take pictures of what's out in space, and that's what we see, that's not true.
Not at all, no.
What it does is it collects and gathers light and data. And then from that light and data, it creates a mosaic of what it is looking at. And that's what the image eventually comes out to be.
It's really not a photo.
It's not a photo at all.
It's data.
No, it's data that's translated into a photo, essentially.
Okay. All right. And here I'm thinking some guys out there going like this with
No.
The lens is really fucked up. No. Okay.
No. Now, what makes the JWST... You mind if I just go into it?
Go right into it, yeah.
Before we get to the pictures. And by the way, for those of you listening and not watching YouTube, I don't know how to describe these pictures other than, wow, that's a beautiful...
First of all, everything that we do now, it's all video.
No, I understand that, but I'm like, if it's going to go on like some streaming sites, which is audio only, and they won't be able to see it. So please, pause this episode and then restart it on some sort of...
Well, it's not even that. What they can do if they want
about.
to, if they're just listening on somewhere that doesn't have video.
Yeah.
The videos, the pictures in which we're talking about, will say what the pictures are, and then they can search the pictures up themselves.
Yeah, I know they got to do a little extra homework. But so the JWST is a unique space telescope because for a few things. Number one, it shoots in infrared and near infrared. It's not true colors, so it's shooting in a different wave on the spectrum. Secondly, it's parked about 1 million miles away from Earth. We just can't go up and fix something wrong and come back down like we've done with the Hubble, which has been in space for over 30 years.
Okay, wait. This thing that we're talking about is not on the planet?
No, it's not on the planet at all. It's about 1 million miles away from us.
We sent it out.
We sent it out.
And so it's the NASA thing?
Yeah.
Yeah.
Go on.
He's confuzzled. Come on.
I
ask
am
the
confused.
Questions.
Yeah, because
say the weird thing. Ask the question.
Ask it.
I don't know. To me, it just befuddles me when you say 1 million miles away. And
it's 1 million miles.
It's still floating around there, or is it landed somewhere?
Nope. It is orbiting the Earth from a point of 1 million miles away.
Now, how quick does this data get back to Earth?
That's a good question. That I don't know. I mean, I really don't. Like, I can't imagine it would take like a long time, but Maybe it's something you can Google real quick, Joe, while I'm explaining other things about it. Like,
I'm all
I don't know
over
the upload-download speed over a million miles.
This is going to be one of those episodes where you have a lot of people, because you talk about the flat earthers and all those dumb people who think about the flat earth like that.
I will not say they're dumb people.
They're
I
dumb.
will just
They're dumb
say,
people.
They're dumb.
you know what? They have a theory.
Then it's a stupid theory because it's been disproven time and time again.
Well,
Yeah, but it's not even that. What I'm saying is there are people who are like, well, it's all CGI images. It's all this. It's all that.
Earth was proven to be round over 1,000 years ago by a bunch of people in ancient Egypt measuring shadows.
I'm not going to go into this.
So no.
Yeah, but continue.
So it's parked about 1 million miles away from us. It has a heat shield behind it, and we'll never get a picture, like a part of it, like along its back, because the temperature in which it has to operate, because these are very sensitive equipment, has to be almost at the freezing point or below freezing, because that's the only way it's going to work. Otherwise, if there's any heat, it's going to fuck up all the data and the equipment, and it's not going to be useful. So people have been asking, like, why don't we have a JWST picture of the Earth or the sun? I'm like, because if you point it back at us, it's not going to read. It shoots an infrared. It's too much stuff. It's too much heat. It'll fuck all the equipment up. It has to operate in a cold temperature, which is why there's a unique heat shield along its back reflecting away all sorts of heat so it can shoot into the depths of space.
Now, this thing is ever recharging. It's got like NiCad batteries and shit on it.
Oh, there's some sort of batteries that make it just keep going.
I think it might be just solar also, too.
Like, there is solar panels along the back, so it is using the heat to recharge batteries, but it's not using...
Real quick, while Hubble's deep field takes days, if not weeks, of exposure, JWST was able to capture images within just 12.5 hours. To put this in perspective, it shows part of the sky approximately the size of a grain of sand held at arm's length by someone on the ground.
Yeah. So if you were to take a grain of sand and go like this, that grain of sand that I'm looking at right now in my hand is the picture that JWST is. It's focusing on that point and gathering as much light from this point so it can turn it into the image that we see and can study.
It's crazy shit. I'm not going to lie.
Well, now, in context of 1 million miles, what's the distance between like us and one of our planets that might be 1 million miles?
Well, I know that it's 93 million miles between Earth and the Sun. Right. I'm not sure what the distance between Earth and Mars is, or Earth
so
and
basically
Venus.
it's not that far at all.
No, it's not. It's far for us because
we're tiny.
We're not gonna like the moon is only 297,000 miles away from us.
Yeah, it's a quarter of a mile.
You know what I mean? So that's a 250,000 miles away, a little bit over that, and that's as far as we've gone. And what does it take? A couple days to get to the moon? Like 3 or 4 days to get there and then back?
Yeah.
Yeah.
I think it's
so
2.5 days to get there and 2.5 days.
Right. So I mean, realistically, it's almost within arms. It's almost within like a realistic thing that we could go.
But we can never fire this thing up to come home.
3 days in regular time, 20 minutes in Armageddon time.
Yeah.
I don't know what that means.
That's a movie reference. So if it's 3 days to get to the moon, that's a 250,000 miles. You're talking 9 days, a week and a half almost to get to the JWST and back if we had to go. But we don't have the technology or the spaceship to get us there right now.
So we know exactly where it is, though.
Yeah, we know where it is.
Okay, now my question is, can we get it back?
I'm sure there's a way to get it back. I don't know if there was ever an intention to get it back. Like, the idea was to stick it out and let it do its thing. And it's been running for the last 2 years.
Yeah.
Okay.
I mean, that's the big thing. They want to get deep, and what this actually allows, which the Hubble, I believe, didn't, is take deeper, more defined space images.
What it does that the Hubble doesn't, it shoots in infrared and near infrared.
Yeah.
Because the Hubble doesn't do that. So when you shoot in infrared, you can see through the clouds and the dust to what's behind it. Because if you shoot in true color or something similar to that, or in a different spectrum, you're going to take a picture of something, you're going to see clouds. But if you shoot in infrared, you don't see the clouds, you see through the clouds to what's ever behind them, which helps us gather more information about what's forming where and what kind of atmosphere certain planets have, that sort of thing.
It's weird. It's very strange because, I mean, that's now what are we gaining by taking these photos?
We're getting deeper insights into the way the universe created, because its range is 13.5 billion years, not miles.
Yeah, basically what we're gaining is more knowledge of the universe.
So you can see into the depths of space as far as we can possibly see using this telescope.
And what's the range on this as far as how long can it be up there? Do we know?
I don't think
Before it calls back to NASA and goes, I'm done.
I think the mission duration, primary mission duration is 5.5 years, but that's for primary mission. They want to extend it to 10 years just to have it keep shooting, and overall they can stay up there up to 20 years. And it launched Christmas of 2021, so it's about to hit 3 years this Christmas.
And you're talking about 3 years. You're almost over half of its original mission.
Yeah. Of its primary mission.
Yeah.
And we've learned a lot of things. We've learned to question things that we thought were well established. They were like, oh, maybe that's not it. Maybe there's something else happening here.
Right.
So there's benefits to having better technology and looking at what's out there. And a lot of people get pissed off because a lot of people think, well, we've already seen these things that you're taking pictures of. Like, why I say taking pictures, not literally, but whatever.
Yeah.
You're imaging things that we've already imaged. Why are you doing that? That's, move on to something new. We want to see new things. Well, when you have new technology, you go back and look at what you've already done to make sure that still holds up.
Right. Compare it. Sure.
Yeah, exactly. Because now if you have new information based off the new technology, then that rewrites what you thought you understood prior, which is why it's not like there's very few things, I think, in astrology that you look at and go, this is it. There's no way else we can. As technology develops, we use that technology and we look at things that we've already thought we knew, and that gains us deeper understanding and new insights. And then there you go. Now we have a new way of defining this thing until the next generation of powerful whatever comes out technology, and then we might have to redefine it again.
Yeah, and that's one thing that people just don't understand when looking at these photos, and they think, well, we've seen these before. Why are we looking at it again?
I think it's because there's a lot of reasons why a lot of people don't understand this stuff, and it's so big.
A lot of people don't want to understand this.
They don't want to, and there's a lot of reasons for that, Joe. People's lives are they got other things to do. They're jaded.
I don't know if it's that, Dad. I mean, that may be a portion of it, but what I think it is, a lot of people in today's world, this is going to be hard to explain without sounding like an asshole. A lot of people in today's world do not like the shrinking God theory, and I think this plays into it.
Well,
I think the more information you gain about the universe, the more further away from religion that you tend to get.
There's an aspect to it, but that's not how I define why people don't understand it fully. I think it's because no one understands. Not a lot of. I think it's because the education system is very good at just saying this is what the basics are, and that's all we require you to pass. And unless you go into that field and really study it or have an interest in it, no one explains to you how shit works. They're like, here's the basic shit, and soon you won't have to get, and pretty soon you'll be able to get into college with a fucking pencil.
Yeah. Okay. So let's get into the actual images themselves. I'm not even going to touch this.
This pencil get in there. It's physics.
It's going to be this. So let's start off with your favorite one, Anthony. Let's start off with
the pillars of creation.
The pillars of creation.
It's like a praying mantis.
In a weird way, you're absolutely right. It does. The pillars of creation, that is located in the Eagle Nebula. It was first imaged in 1995 using the Hubble. This is not the Hubble's view of it. This is one of the James Webb's views of the pillars of creation. And the thing about this is I believe this was the first one they put out, because they put out additional one shot in mid-infrared, near-infrared, and then infrared.
Right.
So 3 different shots, 3 different composites, 3 different ways of looking at the same goddamn thing. What's interesting about the pillars of creation, it's named that way because this is all dust and gases that are collecting to form new stars. All of these little red dots that are sprinkled through are actually new suns or stars. So, with that said, and you know how big a star is, or a new star can be, The trunks, because they're like elephant trunks. These trunks can be up to 9,000 light years long, which means it takes light, the fastest moving thing in the universe, 9,000 years to go from here to the tip. That is how big these things are. And in relative to other things in the universe, it's not that big at all. But for us, it's pretty massive.
But you got it. You hearing you talk.
Mm-hmm.
People, our brains aren't designed to understand this. This is something that is so big, and so out there, like 9,000 miles, 9,000 years to get from point A to point B. People they give up.
Yeah,
that's just too much for me.
It's overwhelming.
Pass the butter. It's crazy.
Right. The first step in looking at and trying to understand the universe and things out there is to understand that you are insignificant in relation to the rest of the universe.
I think about that all the time. I think about that. I think about like when I'll pass a body of water, like I'll be at the beach and I look at that water and I'm like, wow, it's just so vast. But if you really put it down to where, in the context of something like this, it's not even a grain of sand.
No, it's not.
It's less than that.
There are more stars in one image, or rather, there are more galaxies captured in one dynamic image that the JWST provides than there are grains of sand on the Earth.
And we actually have a commercial about our cups.
That's true.
That West did.
There's because you can't sit there and count every single point of light. But there's trillions and trillions and trillions of galaxies, and each one of those trillions of galaxies has billions and billions of planets and billions of stars, and it is very, very vast.
And the most fucked up part is when you're looking at images like this, even the dark spots in which you don't think there's no light there. Could be other stars that are hitting behind that these pictures aren't even seeing.
Correct.
Now,
and that's the fucked up part.
Sorry about that.
No, go ahead.
You see, like, it looks like an arm.
Yeah, it looks like a hand.
Okay, now the upper part of that's all gas, right?
All of it's gas.
Okay.
This whole thing is gas.
Where is the light source that's reflecting on that? Because to me, it looks like there's a light source. Look at the thing like its head.
Yeah.
It looks like there's a light source, but yet you're in a vacuum of space. I don't know. That's what's mind-boggling.
It's not a light source. It's infrared image.
Well, no, you're partially right. There is light sources that are bouncing off of the gas to give us what we see, but those are coming from nearby stars. That's coming from stars that are being formed that are now moving on past. Like they're creating the Eagle Nebula and they get ejected out into the cosmos of space, and sometimes they wind up forming new, planetary systems, or sometimes they just stay where they are.
See, this is what I mean by when somebody says they'll ask you if there's more, if there's life out there.
Yeah,
you got to start to think. I mean, you know what?
100% agree.
It's insanity not to say, you know what, there's got to be something, and hopefully, someday we can actually put a definitive proof on it. But I think we're slowly getting there. But this is it's mind-boggling to me, the vastness and the amount of, like, if our sun was right there, it'd be buried in there somewhere.
Oh, absolutely. You probably wouldn't even be able to see it. It's relatively small.
That's what's scary, because you look at the sun from here, it's like huge.
It is, because it is huge. Relative to us, it's huge.
Right.
But relative to this, it's tiny and insignificant. Like, down here, see how, like, murky it is?
Right.
And you can see some stars peering through and all that stuff. In other images of the JWST's Pillars of Creation, most of this stuff is either thicker or it's lighter, so you can see through and see other stars behind it. Things that we weren't able to see using the Hubble.
Okay.
Because the Hubble was able to see this.
Right.
But when this gets removed because of infrared technology, you can now see clearly the things behind it.
I can see clearly.
And then you can go, oh, wow, that's new stuff we didn't know about. That's interesting. Let's try and define that.
There is the next image is a galaxy within, I believe it's a galaxy. Let me zoom in a little bit on this.
That's the Carina Nebula.
Yeah, the Carina Nebula, which is in the Pillars of Creation.
No, it's not, because it's the pillars are in the Eagles Nebula.
Oh.
The Carina Nebula is its own thing.
I apologize. I'm
Yeah,
stupid.
this is 75,000 light years, 7,500 light years from Earth. It's called the Cosmic Eclipse, and it's the same thing as the Pillars of Creation. It's a nursery for young stars, which means that stars are being formed in this area of space. And this is a zoomed in image of the Carina Nebula because it's much, much, much bigger. It's like if you were on Google Earth and you zoom in at like Seaside Park and you see the shoreline, but then you step back and you're looking at New Jersey. Can you see the shoreline at Seaside Park? You can know where it is and like, well, this is Seaside Park right here, but you don't see the details. Right? Because you're looking at all the way from like New York down to Cape May. So there's no definition there. This is like if you went from that wide scope down and it keeps the definition.
Is it me or does anybody else see a head with a face there?
What?
Laying on its left ear.
I mean, if you're gonna see like that little, there's a on the left side,
like it's looking up,
dead center.
Dead.
Like
center.
here?
No. Look at this.
I'm confuzzled here. Don't
So
bring
am
your
I.
headphones with you.
Well, he's gonna try. I'll narrate.
Does that look like a guy, eyes, nose, laying on his left side?
No, sure
No, you're
Doesn't.
No,
You're-
it just
you're-
looks like a pocket of gas to me.
your face. You're putting stuff together with your eyes.
It looks to me.
What
like
is that
it.
called, Anthony?
Matrixing.
That's matrixing.
Well,
Okay.
Yeah.
you call it what you want, but that's what it looks like to me.
It's called matrixing. Yeah, it's. I mean,
That's
it's fine. And it's like looking at the clouds and seeing shapes. Like, look, I see a
So-
horse or
So
some shit.
the
like
Pillars
that.
of Creation and the Carina Nebula are both baby star making.
Yes,
That's what they are.
They're star nurseries. Yes,
The star nurseries. Okay.
gas, and stuff like that come together. They under extreme pressures form stars. Nuclear fission and fusion, all that shit happen, and then a new
Shit
star
that
is
we
created.
don't understand in this booth.
Well, I don't remember the difference. I knew it once for a TikTok video, and I don't remember the difference between like fission and fusion. But I know that's what powers the sun, because a lot of people think, oh, the sun is just a ball of fire, and you can't have fire without oxygen, so the sun's not real. I'm like, that's not how it works, dumbass. It's
People are
not a
stupid.
ball of fire.
People are stupid.
It's a ball of nuclear fission or fusion. It's one of the. I think it's fission.
People are stupid.
Like that's how it's powered, and like
That's-
heat and light don't necessarily come only from fire.
Right.
Well, we're gonna do one more photo, and then we're gonna go to break. This one right here.
The
This
Southern Ring Nebula, yeah.
Yes, this is a Southern Ring Nebula. It's 8 burst. Nebula is a planetary nebula located about 2,000 light years away from Earth. These side-by-side images show a star's death,
Yes.
gas emanating from a dying star. Both images were taken by NASA's JWST and near-infrared light left and mid-infrared light right.
Right. So this is a good example of the JWST's capabilities. It's the same picture, the same image,
All right.
two different lenses. It's not how it works, but like if you were to take like a camera and I take a picture of you, I put one filter on, I took another, two different filters, I get two different images of you.
Right.
Essentially, for people out there, that's what's happening here. You have infrared light and near infrared light, which allows you to see different things because you can see through the gas and stuff like that.
And what? Sorry.
Go ahead.
Yeah, what's very interesting to me is, I don't know, for the people at home who can't or aren't looking at it or want to look it up, if you're looking at these two things, the left side, which is
That's
near
near
infrared
infrared,
light,
yeah.
you see in the center, you see one bright light.
Yes,
Right?
you do.
On the right, you see two.
Yes, because we didn't know that that second star was there until after we shot it in a different form.
It does look like an eyeball. I do got to say.
Oh yeah, it does. Like a lot of things in
Space resembles
space
the human
resemble
body.
things that we know, but that's how it is. You could also look at like from a biological level, like a microbiology. If you like look at stem cells and stuff or different type, you're like, oh, that looks very similar. It's like, well, yeah.
I wonder what that streak is on the left-hand side.
It's either
I've never seen that.
no, it's probably a galaxy that's on its side from the perspective like this. Instead of looking at it like this,
Yeah.
it's on its side like this relative to the way the JWST is imaging it. So that's probably what it is. Oh, I'm
Now,
only
this
saying-
is not in our solar system, right? I mean,
No. This is the Southern Ring Galaxy. It's a nebula about 2,000 years away from Earth.
2,000 light
years.
years.
Yeah.
Let's get
And what that
straight.
means is, not the light year. I explained that already. What that means is a nebula is this was a star that exploded. It blew up. It died. And when it died, all of this stuff that you see is gas and materials from that star. All that materials goes out into the universe and winds up in different places. Some of it winds up being absorbed into another star. Some of it winds up hitting planets that are local. And some of the materials, the hydrogen, the carbon, that sort of like elemental materials that were born in the center of this star winds up hitting a planet, and those are the building blocks of life. That's how all life exists. Without, like, no planet makes carbon or hydrogen or anything like that naturally. It has to come from the solar furnace of dying stars.
So what
And
what you're telling me is that this basically is just a minor Big Bang.
No. By Big Bang means the creation of the universe. It's theorized that the creation of the universe may have come from everything shrinking down and then exploding outwards, and that's how everything happens, but we don't know that for sure. That's why it is a theory. But in terms of just the way stars live and die, this is its death. Its guts are splattered across the cosmos. Some of it hits barren planets, and those elements go on to create life. And that's how life is. Like, we are stardust, and that's a very
That was me. So you're good.
like, it's whether you choose to believe it or not. It's like you can. Yes, Jesus died for your sins, but the stars also died for us to be here too. I'm not trying to be facetious, but that's scientifically accurate.
Yes, put Jesus.
Put Jesus in the
I
Bigfoot
am not
cup.
taking any chances.
Put Jesus in the Bigfoot cup.
We are going to take a short break. When we come back, we have a couple more
Hold
photos.
on one second. I
Oh,
want to
hold
make
on.
one quick
Okay.
point
Come on.
because it's a good place. See how this star has these 6 tines?
Yeah.
And over there, the equivalent doesn't. It's much shorter. That's because the JWST is taking these images off of a hexagon pattern. So it is imaging it through this hexagonal surface. And as the light hits, because you're gathering it from different angles, and then you're forming it into one singular picture, you get these tines that wind up flying. You can see it again and again throughout a lot of images of JWST. You don't get these tines on planets because as the light's absorbed, it's not absorbed the same way when you're imaging it.
Right.
So that's why people can tell the difference between a galaxy and a star. When you image a galaxy, it doesn't do that instead of a planet. So stars have these tines. These don't. The galaxies don't, because you're not imaging them the same way. So that's why you can definitely tell, oh, that's a star, that's not. And even when it's shot in a different way, the tines are much more smaller, but you can still see them versus where you can't, which is why the center here is a star, and which is why there's 2 of them there, because when you shoot in a different format, you can see different things.
Thank you, Anthony. Very
Yes.
informal. All right. We're going to take a short break. When we get back, we're going to show a couple more JWST photos, and then we're going to talk about what we're talking about next week. So we'll be right back. Please go listen to some of our sponsors and go buy some shit. We'll be back.
Are you a filmmaker, cosplayer, or special effects enthusiast looking to take your creations to the next level? Then look no further than New Rule FX. From realistic props to professional grade special effects equipment, New Rule FX has everything you need to bring your vision to life. Explore their extensive catalog of high-quality products and unleash your creativity like never before. Visit our link in the description to shop now below.
Hey everybody, I'm JC3.
And I'm Mr. West.
And this episode is brought to you by Dubby. Made by professionals in the USA, Dubby was formulated to give you focus and energy with no jitters or crash. Their formula contains vitamins, amino acids, including the patented neurofactor. You know what Dubby doesn't give you?
What's that?
No calories,
No calories.
no sugars,
No sugar.
no fillers,
No fillers.
and no artificial flavors. When the raw ingredients arrive to their FDA-registered and inspected facility that strictly adheres to GMP guidelines, they undergo a quarantine while a small sample of each ingredient is taken to test for any impurities, while also being tested to ensure that the ingredients are actually what they are supposed to be and have the proper dosage.
And once the ingredients pass all the tests, then they're cleared to get mixed into the formula. So head on over to w.gg and use our offer code IsThisRealPC for 10% off your first order. That's DUBBY.GG and use the code IsThisRealPC for 10% off. They have great flavors such as Galaxy Grenade, Dub Sludge, Passion Joy Tea, Monkey Madness, and Dragonade. My personal favorites.
Dragonade right here. I got Dragonade right here. Delicious.
Drink Dubby.
And be better.
These products are not intended to diagnose, cure, or prevent any disease.
Who wants better sex? And who wants better sex starting now? The best way to get started is go to adamandeve.com.
Adam and Eve is offering 50% off just any item.
But that's not all. When you select your one item, you will also get 3 bonus items. That includes a gift for him, a special gift for her, and a gift you'll both like.
Plus 6 free movies for your viewing pleasure and free shipping.
There is discreet shipping as your privacy is priority. Plus 100% free shipping on your entire order.
Doesn't matter how much you spend or what you buy, it will all be packaged and sent discreetly for free.
Don't wait. Better sex is just one click away.
That's 50% off one item, 3 free gifts, 6 free movies, and free shipping.
Bring more pleasure and satisfaction to your bedroom.
Just go to adamandeve.com and select any one item. It could be an adventurous new toy or anything you desire.
Just enter code QUESTION at checkout.
That's question, QUESTION at adamandeve.com.
This exclusive offer is specific to this podcast only. So be sure at checkout you punch in the code QUESTION. That is QUESTION at checkout. And get your 50% off one item, 10 free gifts, and free shipping. Remember, use code QUESTION. Also remember to listen to Is This Real every Sunday at 8 o'clock with new episodes starting July 16th. Remember, everybody, question everything and put that question at the end of your checkout at adamandeve.com. Calling all cat lovers. Are you tired of your furry friend taking over your living space? Say hello to Cat Cave Co., your one-stop shop for all things stylish cat furniture. Their modern designs seamlessly blend into your home decor while providing your cat with a cozy sanctuary of their own. Discover the perfect piece for your feline friend today using the link in the description and reclaim your space without compromising your style. Your cat will thank you.
Hey, fellow truth seekers. Want to take your love for the Is This Real podcast to the next level? Check out our exclusive merchandise line designed for curious minds like yours in mind. From comfy tees and hoodies to stylish mugs and accessories, our merchandise is the best way for you to show your passion for unraveling the mysteries of the fucking universe. Visit our online store at isthisrealpc.com and gear up to explore the universe in style. Don't just listen, wear your curiosity with pride with Is This Real podcast merchandise.
Hey there, fellow truth seekers. Are you ready to dive deep into the mysteries of the universe? Look no further than IsIsraelPC.com, your one-stop destination for all things mysterious and unexplained. From captivating podcast episodes to thought-provoking articles, our website is packed with fascinating content that will leave you questioning reality. Visit IsIsraelPC.com today and join our community of curious minds as we explore the unknown together. Don't just wonder, discover the truth today at IsIsraelPC.com.
And welcome back, everybody, as JC3, Big Joe, and the Pope. We continue to talk about JWST and the images from JWST, which are fantastic images I've always loved these images and stuff like that, and especially the original ones with Hubble and then the retakes with JWST. Amazing.
Mm-hmm.
So let's get into. So right now, the one we have up right now, guys, is Neptune's rings.
Yes, it is.
So this is infrared, like most of JWST. Released in September 21st, 2022. Not since Voyager 2 flew past Neptune in 1989 have the planet's rings been revealed in such clarity. 6 small moons near the planet are visible, while Triton shines brightly to the upper left. The icy moon reflects an average of 70% of sunlight that hits it. And Anthony, you have any more information about Neptune?
Well, it's. Can you zoom in a little bit because I want to zoom in on the planet itself.
Sure.
Now hold on, real quick. Even see, Dad, you can see that like the it's faint, but the 6 tines that go around. Right.
2,
So the
3,
planet,
4, 5, 6, 7.
the planet Neptune has these rings that we didn't even know were there when we first discovered the planet Neptune.
Okay.
In fact, we didn't see any of this until Voyager, like the Voyager spacecraft back when it launched back in the 70s. That was really the first time we were able to see the planet in detail and even discovered that it had rings. And it's shining brightly like this because its atmosphere is mostly helium and hydrogen. So infrared, when you shoot in that, makes it nice and bright. So you can see all of the details, like all these little white bands and stuff. Those are all storms that we never knew about because the atmosphere is so thick. You're seeing through the planet's atmosphere a little bit to the storms that are different, made up of different.
Refresh my memory. Neptune,
Yes.
5th planet.
No. Neptune is 7.
Earth, Mars, Jupiter, Saturn. No.
No, wait a minute.
Mercury, Venus, Earth, Mars.
So Saturn, Jupiter. I think Neptune is 6 then,
Yeah.
because Mars is 4th. Saturn and Jupiter is 5 and 6. So maybe it's 7. It's either the 7th or the 8th. 'Cause then the last one is Uranus.
Right.
Or maybe it's Uranus, Neptune. So it's either 7 or 8.
The last one is Pluto.
Pluto's not a planet.
It is a planet.
No, it's not.
Yes, it is.
So that's it. They're the 2 of the ice giants, this one and Uranus. But Uranus is a big, dumb piece of shit. And I don't
So
feel like talking about that right
You're
now.
an asshole.
I hate that planet. It's
So this
stupid.
one up here, this bright thing.
No
that's,
travel to Uranus.
that's one of Saturn's moons.
Yes.
Wow, it's so far away.
Not really. I mean, it's big enough to. And you see it so far away, but like that's bigger than Earth.
Well, I know it just looks like it's so far away.
It
you
isn't.
know, but okay,
It's
I'll
not.
Just go
It's-
fuck myself.
it's-
You know? So the next one we have is the Tarantula Nebula, which I think is just a fucking.
340 light years across.
It is amazing. September 6, 2022, as Anthony says, 240 light years across. The observatory's infrared detectors revealed a cluster of never-before-seen young stars at the center of the image that were previously shrouded by dust.
You couldn't see that before. We had no idea all those stars were sitting in the center of this nebula, but there they were, and we couldn't see it because
Now,
of the
each
cloud
star
of
is
dust.
another galaxy, right?
No,
No. Galaxies are galaxies. Stars are
Galaxies
stars.
are made up of stars and planets. Stars are just stars.
And nebulas are...
Dying stars that have blown up and now
Yeah.
are
All right. Could they all can they be described as solar systems?
no, because there's
No,
no
yeah.
system. Well, let me put it like this: we don't know what's orbiting them.
Right. That's what I'm saying.
Yeah. So if because you
Because
can
they
only
are suns of some kind.
They are stars, yes, and if it has planets orbiting it, then that is a solar system. But we don't know if they do because we can't get that detailed
Right.
yet.
Oh, wait till we can.
What?
I said wait till we can.
Oh, it's already being worked on. Like the JWST has been designed and worked on since like 1994.
Mm-hmm.
It didn't get launched until 2021. So you're talking like close to 25 years of research and development and money to put into this thing so we can get it there. The next iteration of deep space telescopes is going to be, if they keep the name up, because I think they named it already, but they haven't made it official. It's like in rumor. Is going to be the Carl Sagan Space Telescope.
That would be nice.
But that one's going to be designed to zoom in on planets and be able to see the intricacies. It's kind of, I don't think it's going to go as like Google Earth, where it's like, you know, you have a satellite a couple hundred miles away so you can see it clearly. but you should be able to get a lot closer, and it's going to be much bigger than the JWST.
yeah,
the JWST is the size of a bus. That is going to be like the size of like a space shuttle, or something like that. It's got to be much bigger.
In other words, Anthony, it's not going to be like you could zoom in on Gleep Glorp's home address.
Oh, they're fucking. It's like, no, this is not that way.
So the next one we have right here, this is exoplanet HIP 65426b.
Yes.
So this image shows 4 JWST views of exoplanet HIP 65426b in different bands of infrared light. The bar appearance in the NIRCam images is an artifact of the telescope's optics. The white star icon in each image shows the location of the exoplanet's actual star, which was blocked by a coronagraph.
Yeah.
So this is just different.
So this is different images of a planet.
Yep.
This is the all JWST. This is near infrared. And this is near infrared images, and these are the different colors spectrums in which they shot it in. And why do we do this? So we know that's approximately where the star is in relation to each of where the planet is in each of the photos. And we shoot in different ways because we can see different things. And what are we seeing in each?
Yeah, you're seeing little different things.
You're seeing little different. What are the little differences? Well, those little differences are the way the light hits and reflects off the planet from that star. And that's how we know, like, oh, that planet has an atmosphere of this. Because certain elements burn, or when you shine light through them, are visible in different lights. So, like, when as a kid, I don't know if you ever went camping, but, like, you throw different things in the fire. This turns it green, that turns it yellow, that turns it blue type of shit. Well, elements do something similar in space. So when a planet has some sort of atmosphere, doesn't necessarily have to be oxygen, but when a planet has some sort of atmosphere and you shine a light through it, you see it in this specific color. So if oxygen, say, is always green and methane is blue and hydrogen is red, if you can image a planet as it's passing in front of its star, and you can see what color it's giving off because the light is going through the atmosphere, then you know that planet is composed of this, or it has this element in its atmosphere. And that way we know we can't go to that planet. There's no way we can breathe on it. Like, that's how we know what's the composition of its atmosphere. And that's what it's doing here. It's looking through different spectrums of the color spectrum when shooting in mid and near infrared to see what this planet's made up of.
Yeah. It's amazing, the technology. It really, really is. It's mind-blowing.
And I'm sure I'm wrong about most of the things I just said. So please do your own research. There's people out there who are much smarter than I am who know what they're talking about.
All right, so this one...
I'm paraphrasing all the things that I think I remember from the internet.
So this is the Phantom Galaxy. JWST peered through dust and gas to see a star cluster at the center of the M74, the Phantom Galaxy. M74 is a particular class of spiral galaxies known as a grand design spiral, meaning its spiral arms are prominent and well defined. NASA released this image on August 29th, 2022.
Yeah, again, you can see right in the heart of it where all these stars are, because that's where the most gas was clustered, and now it's formed into stars. And over the course of eons and billions of years, you'll get more and more stars out of all this dust until this dust is no longer there. The pillars of creation will eventually be gone. Like, they'll be replaced by other stars that have died, and you'll see other different formations of, dust and clouds and shit, but
they probably are at this point.
There's a good chance. Like, there's very good chance.
You know how long this light from these stars takes to get here?
Yeah, there's a very good chance that you're absolutely right. They've been gone.
That's what a lot of people. I mean, look, this is, again, it's way too big for the average person to put their head around it. People look at the sky and go, "Oh, look at that star." Not related. That star might not be there anymore.
I don't want to sound like an asshole, but the average McDonald's menu is way too big for the average person.
This is true. Okay. This is very true. I didn't want to go there. I'm trying to keep an upbeat, positive attitude.
Fuck that. People are stupid.
We can see from Earth the constellation of Orion. You have the 3 stars, Orion's belt, whatever. There's 2 stars that are very bright that are part of that constellation. One is I think it's called Rigel or something like that. To the, like, from our perspective in the northern hemisphere, it's to the south of it. To the north of it or above it is a bright star called Betelgeuse. And Betelgeuse is probably already dead.
You said the name twice.
I know. It's probably already dead. The reason we know that is because when we were observing it, and this only happened in the last couple of years, we've noticed that the light has fluctuated to almost where like a piece of it is missing. It should be giving off light, and it's not. And we think it's because it's a very old star that eventually is going to pop and become a nebula and be gone. So it'll be so bright that we'll be able to see the nebula from Earth. It's not going to affect us in any way. But we're not sure if it's going to pop any between like now or 10,000 years from now. But we don't think it's going to live past that.
Do not sit here and stare at your watches.
There's a good chance that it will be observed from Earth sometime in the next 10,000 years of it going out.
Chance to say this podcast will not be picking that news flash up. Or maybe it will. Who knows?
Pretty big fucking news.
Yeah.
Who knows? I mean, 10,000 years from now, it could be like season 2 million. Who knows?
We're just 4 cyborg heads in jars.
No, I'm good. All right, so the next one, this is Jupiter and its rings.
Yes.
So JWST's near infrared camera captured this image of Jupiter showing its Aurora's rings.
Yeah, this to me, Jupiter's always been my interesting planet.
Yeah.
Because of that friggin' eye that they got there, and I know it's a storm.
Yeah, it's a storm.
Yep.
What the fuck is feeding that storm? At some point, storm's got to come to an end.
So
I mean, is there that much energy on this planet?
It's that big. It's a gas planet.
Anthony, what are the
So
what
there's
are the
nothing
moons?
solid there?
It has a solid inner, like, tiny core, like at the heart of it.
Right.
But that's about it.
What kind of gas is on that planet?
Isn't it written down here somewhere? Vague spectrum.
Since infrared light is visible to the human eye, the light has been mapped onto the visible spectrum. Generally, the longest wavelengths appear redder, and the shortest wavelengths are shown as more blue. Scientists collaborated with citizen scientist Judy Schmidt to translate the web data into this image. So, no.
I don't know what, off the top of my head, what composes Jupiter's atmosphere. I don't know.
But
But it's the biggest planet in our solar system, and you can fit a lot of Earths inside of it if you know
You know
think
what
of it
bothers
like that.
me, and
What?
this might just be me being retarded. Sorry. So you're gonna tell me that this basically this planet has no land,
Not on the surface, no.
not on the surface. No, it's gas, right? Gaseous. So we're gonna call this a planet,
Yep.
but Pluto, which is a fucking rock,
You're gonna
at the end,
argument.
is not a planet because it's tiny, because it's a dwarf. Don't say
That is-
midget. It's a dwarf planet.
That is not the only reason why planet is not considered a goddamn planet anymore, and why it's now a microplanet or whatever the fuck it is. Mini planet, dwarf planet. There are other reasons why it's considered a dwarf planet. It isn't just its size.
Mm-hmm. We're not going to get into this argument.
We're not have to get into this argument, but I'm saying there's other reasons why it's a dwarf planet.
I don't care.
It's
what
not
those
just
reasons
because
are.
it's small, so we treat it differently.
Anywho, so what are these bright spots all around?
Those are the auroras.
Those are the moons?
No, those are the auroras. On the planet where your mouse is right now?
No. I'm talking about like these little spots, like these little specks of.
Those.
These are just stars that are like. Is this a moon of?
It could be. I don't know. Like, I didn't take the picture. I mean, it says in its
I know
rings.
you didn't take the picture, asshole. You didn't take any of these pictures.
I think most of them are different stars in the background.
They look like galaxies if you like really.
I can see the tines coming off of them. So I believe they're all stars.
Okay.
This is the composition of
Jupiter.
Jupiter. Hydrogen, helium, methane, ammonia, water vapor, hydrogen deuteride, ethane, and then 0.0004% water.
Yeah.
So
So it's a mix, and that would explain the different bands.
And according to this, it's not solid at all. There's nothing solid.
There's
about
nothing
this
solid about it.
So
I
you're
thought
telling me
I
it's
thought it had a
yeah,
very tiny
it's
core.
a fucking planet that has no land, and we're calling it a planet.
It's not about it's not about what its composition is made of. It's about
Fuck
the
this
fact
fat
that
gaseous bitch.
it's about the fact that it's so massive and it has formed this shape, and it is holding its structure due to gravity.
Yeah, it's just atmosphere.
It's crazy because I mean, like I said before, that friggin' storm is like forever.
Well, you
Yeah,
know what I think? Like
it's
this is a
massive.
storm right here. I
There's
think
many
this
storms
is a
on-
storm right here.
Yes.
This is a storm right here. This fucking planet is so big that these little dots that you see, I believe, are all little storms that are happening, and then you have this giant fucking hurricane type bitch that's
But see,
happening.
that's the
right
thing.
here.
It's a hurricane with no water. It's got very little water.
The-
What is there? Wind blowing? Is that what it is?
Yeah, it's wind and elements and gas, and it's in a very turbulent part, and it's been raging and raging for as long as we've been observing the planet, and more likely for millions of years.
It's
Mhm.
crazy.
So then we have this one right here. This one is the Cartwheel Galaxy. The image of the Cartwheel Galaxy and its companion galaxies is a composite from JWST's near-infrared camera and mid-infrared instrument. NASA released this image on August 2nd, 2022. The Cartwheel Galaxy formed after a high-speed collision between a large spiral galaxy and a similar galaxy not visible in this image.
And every single point of light in this image that doesn't have these tines is a galaxy. This is zoomed in, and we're looking at galaxies now. We're not looking for stars. We're not zooming in to see the
And
the
any
pillars
one
of
of these, yeah.
creation. No, it's not in this image, or the Carina Galaxy Nebula and stuff. Like, you're talking zooming into like this point here to see the definition of like the cosmic cliffs or the pillars like that. And now we're taking a much broader scope.
Yeah, like
And we're looking
you
at-
see, that's a galaxy. That's a galaxy. These are all fucking galaxies,
Correct.
which could have people living in. Well, not people, extraterrestrials, if you will, living in them.
Yes.
We don't know. So
Could be.
this is what's fucked up because we live in one of these fucking things,
This is a galaxy which is composed of stars, and
which
those
apparently
stars-
was a combination of two different galaxies.
right. Just similar to the way in a billion years or whatever it is, the Milky Way galaxy and the Andromeda galaxy are going to collide. We're not really going to. We're not going to be around to see that shit, but like, it's so massive that although yes, they're going to collide and become one super galaxy after that, the chances of Earth colliding into anything and being destroyed is like virtually zero because of how big and how far spaced everything is and how small Earth is in comparison to everything else. It'll just
Thank
get
God
mixed
for
in.
that.
It'll just get mixed in. That's all.
Yep. So this right here is just
The first deep
the
field.
first deep field image. So as Anthony said, when you don't have any of these hexagon things, these are all galaxies in which
Correct.
you're saying, and everything I believe you saw that's zoomed in from the JWST is in this image.
So there's a lot. Okay,
Yeah.
so here's what's interesting about this. You see these striations that kind of look like
These right here.
this,
Yeah.
this, all because it looks like it was taken with a bubble effect. That's a natural occurring thing, and here's what's fucked up even more is this, and these two over here are the same star. It's the same star. What's happening is the star in the center is in between the JWST and the images behind it that he's trying to photograph or take an image of,
Okay.
right? So what's happening is the light from behind that he's trying to image is warping around the star that's in the way to get to us.
Okay.
So the star, you can't move the star out of the way to take the picture or to
Right.
take the image. So the only thing that can happen is the light that is traveling is warping around the galaxy, or rather around the star that's in the way to be captured by the JWST,
Right.
which creates this bubble effect that you see in this picture. Nothing is spiraling towards the center. Nothing's like a black hole where everything's circling. It's not happening. We get these images like this because there's something in the way, and we're trying to focus our equipment on the things behind it. But the thing in the front is so massive that you can't ignore it. Right. So the image and stuff warps around that.
So
Which is that's a good example right there. See how that one's all wonky and shit, all wobbly?
Mhm.
It's only wobbly because the image itself is being warped. The light is being warped as it's bending around the gravity of the star that's in front of it. Other than that, that's not the natural shape of that galaxy. It's probably similar to the Milky Way or the Andromeda or something like that.
that shit is fucking weird.
Yeah, but like the smaller ones in the back are so far away that they don't have to warp because there's not a lot of information being processed around the star.
That shit's crazy. I'm not
yeah,
gonna
so
lie.
you get a lot of these warbles around here and stuff, and they're all the same galaxy. It's just that it's warped in such a weird way that it
All
looks
right.
like there's more than there is.
Let's go. And here's our last one. This is Saturn.
Saturn, yes.
Yes, Anthony, take this.
So you know how it looks? It looks like baby shit.
Okay.
Okay.
That's because Saturn is made of methane. Saturn is made of atmosphere is made of methane. Methane does not glow under near infrared imaging. It dulls it, dilutes it, absorbs it almost. So that's why it looks like this. It's not bright at all. The rocks and stuff, the rings are nice and bright because it's made of different material. So we can capture that in near IR or mid IR, whatever.
Mircam.
Yeah. Can't do that with the planet itself. It's just like it absorbs it. So that's why it looks so weird.
That shit is
Yep.
ridiculous.
It's the only planet in our solar system that does this. Everything else reflects it nice and crazy colors and different wavelengths. Saturn just turns to baby shit.
All right, so that's our last image for this. Dad, I just want to get you real quick because I think we all know how Anthony's, he loves all this stuff. He researches all this. So, we have many videos on our TikTok page with Anthony talking about this stuff, in which he is going to start up on his own page and on our TikTok page again with doing different stuff that's coming out. How do you feel particularly about this stuff? Because it's you're right. We've been saying it through the entire episode that this is very massive and a lot of information for the average person to try and understand.
It's tough to absorb because it's so huge, and there's no mystery why Anthony is so into this. I mean, as a kid, this is what I studied. Not to this extent, obviously, because you didn't have
the technology.
We made a little model on the ceiling and everything. And we thought it was a big deal.
I mean, you were kicking your feet through the bottom of the
when I was a
chair.
young kid, I always wanted to be an astronaut. That was my first goal. Until I realized I had claustrophobia and there was no way of getting that fucking little capsule. Anyway.
Motherfucker can't get into a plane, but he wants to be an astronaut.
Well, you know what? You don't have fear.
Apollo 13, my ass.
Yeah, right. Exactly. You don't have any fear when you're a kid. But that aside, it's very massive and it's kind of bittersweet in a way for me. And because now, you come this far and you got all of this stuff and the possibilities are endless and you'll never see the possibilities. You'll never see, long after, we're all dead and gone, 5 million years from now, if the planet is still here, we're still going to be progressing. Can you imagine 5 million more years what we are going to be able to do with stuff like this? I mean,
yeah, but okay.
But you're real quick. I just want to. But you're talking about, yes, whatever the hell you want to say. Like for me though, like the information of which we're talking about, you're only talking about maybe 200 years of really.
That's my point.
Exploring space like we know it today
with science. Space
well,
has been explored forever.
Space has been explored.
We've observed forever. The last couple hundred years, we've actually put like technology and tools to that.
Yeah, that's
thing,
fine.
what becomes
that's
a strong.
Yeah, so that's why, like, I understand you needed people to think about the sky before we actually started exploring it. Like that's the first step to every exploration. Talking about exploring the world, our own world, and then exploring outside of our world. So I when I talk about stuff like space, for me at least, I really just talk about maybe the last 150 years in which we've have starting putting stuff into space, and really discovering stuff like in our own solar system, beyond our solar system, now beyond our own galaxy. That's where the more interesting stuff, for me at least, comes in. I don't know about you two. I know for me, like when I think of stuff like this, it's really from that period now.
Well, Dad mentioned what it's going to be like in 1 million years or 5 million years as far as understanding and technology. But let's look at the last 30 years.
Yeah.
You know what I mean? Like the Hubble was the hottest thing. Like that was the brand new technology. That was only 30 years ago.
Right.
You know what I mean? Who knows? The Carl Sagan one that they're working on now that maybe will get off the ground. Maybe that'll be another 30 years.
Yeah.
You know, I mean, it's all relative to where you exist on the timeline. You know what I mean? I'm sure there was people who really want to see like, ooh, that movie's coming out next year. Who ain't gonna be around to see it just because something's gonna happen to them? It's just dumb luck, you know. But we happen to live in a time where technology is advancing at a rapid pace.
Yeah, it's a double-edged sword too.
Yeah, it is. But like, it's advancing at such a rapid pace that when you like, all right, it took us 30 years to get JWST there, but maybe it'll take us 15 years to get the next one up, or we could put something up in the next 5 years that's not as good, but it's going to hold us over because it's going to do something unique.
Right.
That will be a integrated feature on the next big one that we put out there. So it's just one of those things where of course we're going to know things in a couple 100 years that we don't know now. But there are things that we're going to learn in 5 years that we don't know now that's just going to be just as mind-blowing.
Yeah, I kind of correlate it with the iPhones. You go out and get an iPhone, say you get the iPhone 10. By the time you get that thing fired up and you use it for a month, the iPhone 11's already been released.
Yeah. So
you got to go upgrade. So that's how fast technology is advancing. And I think to your point, Anthony, it's just going to get rapid fire because with every,
barring any, I mean, this may be the pessimist in me, but barring any really catastrophe that melts all technology.
Of course, but there's also there's a reason why we didn't go back to the moon. It's because there was no money. It's because we decided to put the money towards other things on the Earth, and we said, well, we went to the moon. We don't have to go back, and that was a mistake in my opinion. But you make choices when you have a country to run. You have do you service the people or do you service? Let's put it towards NASA and have them.
That's the age old question. I remember when they came back with the moon rock, and we had one in our class. Was it a real moon rock?
Who the fuck knows? Yeah, exactly.
But I came home and told my grandfather, I said, "Pop, we had a moon rock." He goes, "That's not good. Is that going to cure cancer?" I said, and as an 11-year-old kid, you go, I have no answer. I don't know.
You don't know.
But the reality is, the more you know,
yes,
the more you might get something that can cure something on the planet.
Here's something that I heard it on the way over here just now. That there is a doomsday vault in Norway where we keep the seeds
right.
and example and biological tissues for whatever in case something goes extinct. We can always make more of it, whatever. But because of the way the planet is warming up, whether it's man-made or it's natural, it's in danger of flooding. The option is to build a doomsday bunker on the moon, put it into the moon, and that way you can store the things there because it's cold. It's away from any atmospheric problems because you're going to do it in the moon and not on the surface. So because the moon doesn't have any atmosphere, it's subject to radiation from the sun. But if you build it in the moon, it blocks that radiation. There's no water that's going to flood it. There's no way it can erode. It's just a dead rock floating around our planet. So scientists are kicking around the idea of installing that doomsday vault on the moon because you can keep things in pristine state without any damages from any sort of outside interference. But if we found out that the moon 60 years ago was made up of a radioactive material, that would be out of the we wouldn't even think about putting it up there. We wouldn't even go back because it's dangerous. Wow. Of course, it's not going to cure cancer, but at least we know now that we can do this plan from it, and we can do something else on the moon.
See, I'm not a big on the doomsday thing, and I'll tell you why. Because if the planet's coming to an end, and just because you have some seeds left, where you plant them?
Well,
That to me, that's a big question.
The idea is if the
Grow
atmosphere,
some potatoes and peppers. I mean,
if the atmosphere gets that bad, you install some sort of bubble, and you live in bubbles and filtration systems and shit like that.
I want to be at ground zero when
But
it happens.
yeah, okay, that's one way of looking at it. But like, you would have to do that in any planet that we can get to in the relative near future, like Mars. You can't live on Mars like we live on the Earth. There's very little. The oxygen is so low.
Not unless you nuke it.
I'm not gonna fucking nuke Mars. But you would have to set up some sort of system where you live in a bubble.
Call back to
and then if you could
7.
terraform it and you make something and make an atmosphere, that's one thing. But that's like almost science fiction.
I just don't see anybody. Are we going to start a shuttle?
Well,
to
that's how you
move back,
terraform it.
You know,
Like
I don't know. It's
nuking
just a
it.
very, very. To me, it's always been a dangerous concept.
Well,
It would shut the flat earthers up.
Well,
Look, they're on the fucking moon. Tell me the earth is flat.
we
Get on the fucking spaceship, Jethro.
that's
You'll be able to see it with your own eyes.
That's all we have for this week. That's all the images, at least, we have for this week. Next week, we are talking about creepy things within our own solar system.
Cool.
Which
Me?
No. That's within our own
And
planet.
99% of them are on this planet. But go ahead.
But yeah, so there are things floating within our solar system that are actually really fucking creepy. Shit that we've talked about this, the thing that we've sent out and that's playing music all the time. That's creepy to me. That's just weird. But
You're talking about the Voyager?
no, I'll explain
Okay.
next week. But yeah, so that's what we're doing next week. Anybody have anything else to say?
No.
No.
No. All right, we'll catch you guys next week. Thank you for joining. Remember, everybody, question everything, and please go look at all of our stuff. Go to YouTube, social medias, and stuff like that. We will catch you guys next week. Good night.
Adios, motherfuckers.